side. So in this section, we want to look at measurement of superstructure walls. So we want to look at measurement of superstructure walls. Good. But we are starting with a work example. And the question says that figure 8, drawing number 3, shows a plan of a detached house of an attractive design. The accommodation include a good-sized living and dining room, 2 bedrooms entered from a utility of the living area, shower with separate WC, a spacious kitchen and entrance porch. External wall are of 150 mm thick solid concrete block built in stretcher bond in cement and sand mortar of ratio 1:3. All internal partitions are of 150 thick hollow lightweight concrete block built in stretcher bond in cement and sand mortar of ratio 1:4. Take note that the roof is 150 mm thick reinforced concrete slab. The room height is 2,900 mm from floor level to ceiling in all rooms. So over here is the drawing we are talking about in the question. Okay. And if you look closely over here, you can see that there is a note over here. And this note has some form of specification. That is the door. It's saying that all doors are 2,100 by 900 mm measured over frame. Also take note that the window, okay, that is for the windows. The WC and bathroom are 900 by 600. You take note of this one. So this is a very vital information. We'll come back to it later. And others, 1,800 by 1,200 high louver types. Okay, so all of them have this height, but for the WC and the bathroom, the height is 600. You see, by the spread, or let me say the length is 900. For the lintel, the size is 225 by 150 mm reinforced concrete. Okay, and then the room height. Let's see the room height. This is the length we just spoke about, and then the room height. This is the room height over here. All walls are 2,900 mm from floor level to ceiling level. Okay, so that is it. Let me just quickly zoom this and let's see what the plan entails. If you look closely over here at the right side bottom, you realize that this plan over here is a what? This is a proposed 3-bedroom residential building. You see, so that is the title of the plan. Exactly. And so this is a proposed 3-bedroom residential building. You see, as simple as that. So that is what we are coming to work on. Run by Elna. That is the date was 20. Let me say it was in April. So this is the scale. The scale is 1:100. And then this is the ground floor plan as stated over there. So that is it. Proposed 3-bedroom residential building. That is the title. Always make sure to check for a title. So now this is the plan we are having over here. I believe we can all see the plan. Very good. At this point, I expect the students to have a pen, a paper, and then a calculator beside them so that some of the calculations that we are going to be doing over here, they can be able to work. Okay, very good. So this is what one of the bedrooms. This is also another bedroom that's seen over here. This is the living area. You see the dining. You can see the kitchen and then you can see the utility. So, from what are we going to do next? Let's just quickly move to our take-off sheet and see how best we can down. But even before that, this is our estimate 7. I expect each and every student to have their estimate 7 beside them so that they can be able to practice along. If you have a soft copy of this, do all to print it so that you can have a hard copy. It's always good to practice with a hard copy because in the presentation, that is what you are going to use. Yes. So this is our take-off list. Good students can just quickly draw it down so that once they begin, they can be able to jot down something. And this is the schedule. Okay, this is the schedule for the drawing. So you can see that in the schedule, you have this is the location, the ceiling finishes, also the wall finishes, the floor finishes, and the schedule. They have all been provided specifications that are put at the kitchen. You come to the kitchen, they are saying about 10 mm to cement and something render, of which one is before. So that all the specifications are provided for you. And even in the living area of what you look at, each ceiling finishing is what 4.5 mm plasterboard, 3 mm coated finish, 2 coat emulsion. So you see that the finishing for the living area, it has specification has been written for it. So that is how it is. We use one match focus. So let's just move to our take-off sheet and then let's see. So you said that anytime you have you want to begin with a work, you are supposed to put down your project title, your date, your drawing skill, your SMM you are using, the drawing number, and then you put on your take-off sheet and then you can begin. So let's all quickly do that together now, quick, and then let's proceed. So we say I'm going to put down first, if I'm going to put on the project title. Exactly. So you put down your project title, the date, the drawing number, the SMM you are using. We are using SMM 7, okay? That is why I've written SMM 7 over there, and also you put down the drawing skill. Then from then, what are you going to do? You realize that the topic we are looking at mainly is called superstructures, and then in here we have only external walls and then internal walls. So those are what we are going to be doing the pick of. Because we are taking off for superstructure walls. Yes. So in our take-off list, we are going to write 1. We are going to take off for external walls, and later we also come and take off for the internal walls. See, very simple as that. So let's quickly write or put down our take-off list. Let's put down our take-off list. So this is our take-off list. So right over here, take-off list. So this is our take-off list, as you can see over here. Then our take-off list, after writing take-off list, and we are going to write external walls, and 2, we are going to write what? The internal walls. Yes, take note that some of all these things are track marks. Okay? And failure to do some of these things will cause you to lose marks. Very good. So this is external walls. So you see, so this is external walls. Then later we're going to write what? Internal walls. And we can now proceed. You see, very good. So this is our internal walls. So this is our internal walls. So we say that internal walls, you see. So our takeoff is composed of one external walls and then the two is what internal walls. So I just want to indicate it and then put or better so I can just put asterisks over there. See, yes. So that is our takeoff list. So we are just going to pick one of them and then we begin to lay more emphasis on it to just put the see the way. So we are starting with the external walls. Okay. Straight away, external walls. So let me show you the external walls. This ones over here are the external walls. You see this was the one I'm using the marker to move around. These ones are the external walls. See these ones. All these ones you are seeing over here, they are the you see this. They are the external walls. You see. And I'm coming to use a green marker to go on a certain ones, and you know that those ones are the what? The internal walls. So these ones you are seeing over here, all these ones are internal walls. You see all these ones are internal walls. So you want to take off for the external walls, and when you're done, you come and go for the internal walls. You see, yes, exactly. Very, very, very easy. You see, so the ones that I use the blue pen are the what? Internal walls, and then the one you are seeing the blue pen around is the external walls. You see, very, very, very good. So good students can go all to type their questions in the comment sections, and then I'll review it for them and give them more feedback. Better still, don't forget to subscribe to the channel, like the video, and share for more. Exactly. So we are just going to pull down the one we are beginning with, and the one we are focusing on now is the external. So let me quickly write that down. So this is we are now focusing mainly on external for our calculation. Then when we are done, I can take the internal walls to see the external walls. The external walls. So to the external walls. So in the external walls, what are we going to measure for first? You see that the walls that we are calculating for, they are bricks. It could be bricks, it could be blocks, okay? And all this one, they are measured under what? Masonry. So they are measured under masonry. If you open the FMS setting, that is F10, you see it over there. Also, I want you to know that structures are measured in what? Area. Okay. Yes. The superstructure walls, they are measured in what? Let's say area. Okay. So first of all, what are we going to do? We are going to look for an area. What do we say? We say that area is equal to what? Length, you see, times breadth, you see. Good. So we are supposed to look for the what? The length. We also come and look for the breadth. We multiply to get the area. You see. So just from this idea that you have over here, we need two dimensions. Straightforward. So first of all, let's go and look for the what? The length. The length. Okay. So let's look for the length of the whole. But to get that total length we are looking for, take a look at something. From this place to this place, okay, from here to here, the total length is what? This is that the 15,000, 15,750. But this all these points over here are the dimensions over here are only. So in SMM 7 2, we said that you want what is what. So you can divide it by 1,000 to make it quite easy. So you say 15,750 divided by 10. That is, you're going to get 15.75. So you come over here and then you work systematically. So let's write over there down length. That is the length we are dealing with. And then we proceed. So this is the length. Okay. The first thing we look for was the what? Length. So I put over here the length. Then I circle, I underline it length. So the length, we are going to consider both sides. You see. And so I take this side and I'm also going to take this side too. I take that this is a porch. This one is not a wall. Okay. This is just a porch. Okay. And so we focus on the main one. So you see that this whole value over here that you are seeing, that is 11,300. I'm going to subtract what this thing from it. Or better still, we are going to subtract this number from it. Or better still, we can still take this value. You see, this one is minus the what? Porch. So we are going to take what? 9,050 millimeters. You see, yes, we are going to take 9,050 millimeters. So this one, when we divide it by 1,000, we are going to get 9.05. 9.05. As simple as that. So let me quickly put that down. And then these are the values that we are working with. I said that over here we are not considering this porch because it is not an external wall. It is not an external wall. So the real external wall begins from here and then it ends from here. That is for the width of the group. But the length is for 15,750. As simple as ABC. So let's put down the various things that we have noticed. We'll find them. First one, I'm writing what 15. So 15.75. So that is 15.75 meters. So you see, I just converted it to meters. So that life can be easy. Then second is what we had 9.05. Just straight from the ground. So this is what are we going to do today? So that we are going to add them. Yes. Yes. We're going to add them. So the rule we are adopting is for add. So I'm going to write it over here. Add. We are adding them. We are using the laws of measurement. Okay. And I continue to say that the laws of measurement are so if you add this, that is what 15.75. 15.75 plus what 9.05. You are going to get 24.48. But taking that is just for one side. Okay. So this is just going to give you 24. That's just going to give you 24.80. So see, this is what 24.80. Okay, so let's go back to the video and let me show you something. Take note of what we did now. We just took just this long side like this and also what this long side. Okay. So now we have to come and consider this and you have to add this and this. So what do we do? Since they are of the same dimension, we just multiply it by 2. Okay, this dimension and also this place. So we come over here and come and multiply this by 2. Then we can get the overall length. Okay. Yes. So of the external wall. So from here we just multiply this by 2. Then That is it. So the multiplication is how we're going to do. We put this sign over here and then multiply all of this by 2. Okay, that is 24.80 times 2 is going to give you what? 49.60. 49.60. Then from there, we are just going to less comments. See, isn't that beautiful? So this is going to give us 49.60. 49.6. So you see, as beautiful as that. As beautiful as that. Then from here, what do we do? So we are going to less corners. Okay, the corners. You realize that pillars are going to be there. So we are going to less the corners. We are going to less the corners. Okay, we are going to less the corners. So since the corners are 4, 1, 2, 3, 4, we are going to what? Less them. So and the thickness of the block is what? From the question, it's 150. You see, external wall are what? 150 mm. Solid sandpaper block. So that is it. So we are going to less corners. So we say that less corners. So we are going to less corners. So in lesson of the corners, we realize that it's just going to be what? 4 times 0.15 dot 150. The thickness of the block that is 150. If you divide it by 1,000, you're going to get what? 0.15. This is what is 1. And that is going to be to become what? 0.15 times 4. So that is it. So I'm going to write it right here. That is going to become what? So 4 times, this is a symbol for multiplication. 4 times what? 0.15. Okay. So from here, what did we get? To be more coherent and for us to be more logical, let me use a different color pen. And that is going to be what? 4 times 0.15. Okay. And 4 times 0.15 is going to give us 0.6. See? So finally, this is going to give us what? 0.6. Okay. And 0.6 the same as what? 0.60. So since you said less, the word you heard was what? Less. Also, for you to understand, let me use a different color pen to denote that, to drive a meaning to you. So the less, as we all know from the beginning, is what? Subtract. That is the symbol for subtraction, the measurement of subtraction. Okay. So when you hear less, it means that you are subtracting. You see? So we are subtracting what? We are subtracting 0.60, that is the corners, from the total length that we have. That is 49.60. And when you do this, you realize that you are now going to get, if you do this, you realize that you are now going to get what? Just 49.00. So after less than the corners, our final answer became 49.00. That is 49.00. Very good and beautiful as that. As beautiful as that. So you see over here, there is no space over here. Since we are done calculating on this, we can just cut 2 lines and direct. Yes. So we just draw two lines and that is or better still because of the space, I could create and rewrite it again so that you can still achieve what you're supposed to learn at the end of the day. Good. So we had 49.00, 49.00 after the subtraction. After the subtraction, 49.00. You see, as bottom of that. So we just continue to go and do our description here and then we square. So we come to this side. Let's come to the right side of the paper, please. And then come and pull down. You come and do the squaring and then the description. And back into here. So from here, the answer we had was what I told you that this is the answer column. This is the dimension from this and this is what this is the squaring column and this is the what description column. Answer, dimension, squaring, and description. Exactly. Exactly. So the total length we had over there, we saw it's 49.00. So I'm going to put that in there. That is what you are seeing over here. 49.00. And so the overall length of the building. That is this one that you are seeing over here. The room height. See the room height. The room height was what? The room height was 2,900 divided by how you are going to get 2.90. So we are going to multiply that by the overall area. Okay. So now also that is this times what 2.90, 2.90. 2.90. So from here we can just multiply and then we are going to get 142.10 to 142.10. So that is going to give us 142.10. One four two point 10 as you have seen over there. As beautiful as that. So here we can just do some description and then we are good to go. As I was telling you initially, in your assignment 7, you have everyone, I expect you to have your assignment 7 beside you so that you can practice what we are doing. Okay, very good. So you open to your table of contents. Okay, in the assignment 7. So this is the summary of context. So we are going to alternate in the bottom block first. So this is the one underline so that the better still can use that in the book. We're going to column F. Exactly. So this is A, B, C. So I'm just putting the asterisk now. You see, yes, so we are going to open to what F10, and this is F10 over here. You can see F10, and that is what exactly. So this is the F10 that we have opened to. And you see that the F10 that we have opened to, it is the what mixing. You see, mixing. So in here, in the F10, our main focus should be on the quantification. You see the classification. Exactly. 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 So I want you to know that you see that the walls, listen, they are measured in meters squared. So that is what I told you initially. It is also showing the diagram. You see, so the walls, that is what we are doing over here is a block wall. So we say that the description that I'm going to use is F10.1.1. The wall is 55.1. This is how the description is going to be. Then we are going to say that block work wall of thickness 150 concrete block in stretcher bond in concrete and sand mortar is the ratio 1 to 3. So let's all write that together. So we say that our description is going to be block wall thickness 150, or we can say that 150 solid concrete is of solid concrete blocks in stretcher and mortar ratio 1 is to simple as ABC. Okay. As simple as ABC. As simple as ABC. Okay. Okay. So that is our description. That is our description for um, the, the takeoff that we did. It has got windows. If you come over here, this has windows. The external walls, though we are taking for all the external walls in the height, or we've taken the area, but even the area itself, it has windows. So the various windows, we have to deduct the windows. If you don't deduct the window, it means that if you don't deduct the windows, it means that you have included all of them, and that makes your measurement inaccurate. So we have to deduct the windows and then the doors that are in the openings of the external walls, so that we can get the actual figure. So let's come here, and then we're going to do our deduction of it. So this is how we're going to go about it. So for the description, I took it in the S7 that I just showed. So it is what F10 of 150 solid concrete block in better bond in cement and mortar of 1:3. So that is it. So we are coming to the duct. So we are coming to the duct, the windows, because we just want the block itself. So the word is deduct. So we are going to write deduct, deduct, into the difference in the CFP. Okay. The same description we wrote for the calculation of this one is the same thing we are doing for the other one. We are still on the 10 hours. So this is it. Let me underline it for you to see. So we are going to deduct. Okay. Going to deduct the lintel, the windows, and the doors. They have the same description. That is why I put the detail over here. If not, I'll come and still pick these days and come and put over here. I'm coming to do squaring and then I'm going to do the squaring for those ones. So watch. So over here, this is going to become I can put this bracketing sign down so that we don't forget. Okay. Yes. Okay. So that is it. We'll close it once we get there. So the first one we calculated for is the hot overall length. And the overall length we had hot, that is the main gate, we had 49.000. So this 49.00, you realize that since the length runs through the building, we will multiply that by the hot length. And the length, what is the value for the length? This is the length over here that they are saying like this 225 by 150 mm. Okay, so if you draw the length like this, realize that this side is the truth and then the top of it is what? Just 150. As simple as that. If I intentionally draw it this way, you see what I'm talking about. Okay, so like something that I just sketched over here. So as you get to be 225. See, yes, and then here is 150. So we'll keep the blocks like this to keep them like that. And then the 225 is also there as simple as so let's proceed. Good. So the length runs through the building. So we're just going to multiply that with the 225. 225 divided by 1,000. We're going to get 0.23. Okay. That is 225 divided by 1,000. We're going to get 0.23. And that is because we are just maintaining 2 decimal places. You realize that you have to run the other value. Okay, so 0.225. If you run the 5 to the 2, is going to be proper. That is why I can use 0.2. See, very good. So we're going to write out 49 times 0.23. 49.0. So from here, I can do next. That is, we have Very good. So, 0.23. 0.23. 0.23. Exactly. So we just split, multiply. And if you multiply, I'm going to get 11.27. 11.27. This one I did over here is for the length of. We don't write it over here. This is for the length of. So this one is for the length of. So secondly is that we're also going to look for the windows. Okay. The length is one since it runs throughout the building. That is why I multiply it by the total length of the building. And I have this. So what else am I going to do? That is, I'm going to focus on the what? The windows. Okay. I'm going to focus on the windows. So for the windows to better still, I can write it before I come and do the calculation for it. And vice versa. So this is the length like it over here. This is the length. That is for the length. So let's come and also do for windows. Let's also come and do for windows. So for the windows, take note that it's just the external walls that we are focusing on. Okay, so we're looking at the windows at the external surroundings. Okay. Yeah, so of the walls. So over here, if you focus on the dining, the first one, what can you see over here? Let me just quickly zoom this so that everyone can see this well. Over here, the dining is what? 3,600. Isn't it? 3,600. Yes. So that is just this is the window for the dining. No, the window for the dining you are seeing over there is what? 2,700. 2,700. This is it over here. 2,700. Okay. Yes. And then the window for the kitchen also over here is what? 1,800. The window for the storeroom over here is what? 900. The window for the WC, that is the length is what? 900. It continues like that and it proceeds. So let's take time and then we see how best we can use these dimensions to start our table. Okay. Use these dimensions to start our table. So first of all, let me come and start from this side. Okay, so from this side, you realize that the total length of the window, okay, is what? So that is we are starting from the hot living area. So we are not starting from the dining room, we are starting from the living area. Okay, so if you take the plan, focus on the living area, you will see the long window over here, 3,600. The long window over here is what? 3,600. So that is from here. It begins from here towards here. See, yes, 3,600. So these windows, what are their heights? Let's all come back to the little over here, with the over here. the room height. You realize that for the windows, they are saying that these windows, that is, it's only the WC and the bathroom that has a height of what? 600. Their height is 600. Okay, but for others, their height is what? 1,200. For other windows, their height is what? 1,200 high. So this length that we are seeing over here, 3,600. We are going to multiply it by what? The length of the over here, 3,600. We are going to multiply it by 1,200. Okay, we're going to multiply it by 1,200. So this length of this window in the living area. So it's going to become what? 3,600 divided by 1,000 is going to be 3.6. Okay, times 1.20. You see, so that is how it's going to become. So here is going to be what? 3.60. 3.60. 3.60 times what? 1.20. Very good. Then from here, you can just multiply it. Well, it's just one. If you look to the plan, it's just one. This is the only longest window in the plan. So if you multiply this, what are you going to get? You're going to get 4.32. 4.32. Then from here, we are not done with the windows, okay? We are still measuring more windows. So let's go to the dining. Since we are done with the living area, now let's go to the dining. And then the window at the dining is what? Cut it over here. It is 2,700. From here to here, 2,700. You see, 2,700. So this is going to be 2.70 times 1.20. So what's the price? So right here is going to be 4.70, 2.70. Times what? 1.20 times 1.20. So that's beautiful. And then if you multiply this one too, you're going to get what? 3.24. 3.24. 3.24. So what is the next one we are going to right away? Yes, let's done. So now we are done with the living room and then the dining. So that is, let me quickly on zoom this a bit. Yes, we are done taking the windows of the living area and then the dining. So let's also focus on other ones. But if you take a clear look, let's count them. You realize that the 1,800 are four. This is one. I can just use a different color pen to give it so that you can enhance your understanding. So this is what? 1, 2, 3. So that is the key. One is in the kitchen, and one is in the hot bedroom. So we do it over here. And then what is the other one? This is another one on the back here. So it all becomes right. All becomes right. Then what is the last one? I can see another 1,800 over here. So making it to be a total of just, you see, so it's going to be 1.80 times 1.20. So that is how we're going to just multiply. Okay. It's just as simple as that. Look at the windows over here. 1, 2 bedroom. One has what? 1 window. Then the bedroom. 2 has what? 2 windows. Then the all have 1,800. Okay, work in the kitchen also have that kind of thing, So 1, 2, and then 3, 4. Okay, so you see, yes, so what? So this is going to be what? 4 times 1.80. So I'm going to put a 4 back in the times in column. So that is going to be 4 times what? 1.80. 4 times 1.80 times what? 1.20. So this is the result 1.80. So that is 1.80. So times 1.20. All things therefore 8.64. So that is all of this million. 8.64. 8.64. Then from here we are now going to the washroom windows. So we are done taking these windows too. So let me shade them. The ones we are done taking them, I'll just intentionally shade them. These ones too, we've taken these ones already. All these ones we are taking, so that is why I'm shading them. So that you understand this ones we are taking this one already. This one we are taking this one already. So what else? This one too, I've taken this one too already. So I'll shade it. So we are coming to the 900 one. So that one I would like to use a different color pen. For this one that we do too, I'm still using green color pen to shade it so that plenty people will not be confused. And this one too is done, so that is why I intentionally shade it. I just wanted to have some different views. Yes, so this one too, taken that is the longest window, 3,600, just for more ventilation. So we are coming to now focus on the storeroom, the WCN and the back. Take note that the WCN and the back, according to the details they gave us over here, they have a WCN, but they have a height of 600. Okay, so you can just go and multiply 900. You see 900 is over here for this. Then we use different color pens to also shade them. And that is the this one over here, you can see the yellow pen. Not that one, this one, the WC and then the back. The WC and then the back. So there are two. There are two. So what are we going to do? Is this the formula is very easy because 0.90 times 0.60. You see. So the ones I just so this is let me just shade it over here so that you see that we are taking account for that and we're not going to consider that again. So it's just 0.90 times 0.60 as important. So this is it. going to multiply 2 times what? 0.90. Zero point nine zero times what? 600. So 600 divided by 1000 is 0.60. So all of this, if you multiply, all of this, if you multiply, you're going to get 1.08. You're going to get 1.08. Then let's also go and focus on the other 900 window. So the 900 window, the other 900 window, this is over here. That one, so I'll intentionally use a different color pen just to give you a nice understanding. So for this 900 window we are seeing over here too, take note that this one, its height is different because others have a height of what? 1,200. So it's going to be what? 900 times what? 1,200. So that is what I'm going to write over here. So over here has been shaded now, and that is what I'm going to write. So now it has become what? Let's go. So that is going to be 0.90, right? So 0.90. Because 900 divided by 1000 gives 0.90. So times 1.20. 1.20. So this one, when you multiply this one, you're going to get 1 point. So if we are setting, let's see, 1.08. We are not done. We still left with some windows somewhere more. So let's still come back to that one. When you realize that over here there is a certain window hiding, but they didn't even stipulate it. Okay? They didn't give it any dimension over here. So if you don't look into the plan carefully, it will keep you. Let me just take my pen first and then I'll go and show you. So yes, I'm going to use, let me use this color. And you see this window over here. This is a window over here. I'll just circle it like this. See, this one over here. It's a small window which has a dimension of what? 600. That is the length. It's attached to a door. Okay, 600 mm. The students should be able to know that. Okay. So I'm just going to shade it myself for you to see. 600 work on now. That is the one we are going to. So this one, the height is as usual, 1,200. So we come over here, it's still the same thing, and that is what? 0.60. 0.60 times what? 1.20. So the 0.60 times 1.20, what are you going to get? 0.60 times 1.20. I'm going to get 0.72. 0.72. That is 0.72. You see, Then from here, what next are we supposed to do? We realize that we are done looking for all of the windows so far. So let's go and check if we still have any other window somewhere that we have not taken off for. So it's just the external walls, okay? So realize that we are sticking for all the windows. This one's over here are doors. So there is a door over here, there is a door over here, there is a door over here. But all the windows we have included them in the calculation spreadsheet. So the next thing available for now is the door. So that now when we were shading it, it has led to what? Coherency and accuracy. You see? So how many doors do we have opening at the end? We have 1, 2, 3 doors. Okay. But taking that this one is 900, this one 900, and this one is double door. And even the dimension is stated over here. It's a double door, you see. So the opening was stated as simple as that. Okay. So let's proceed. Okay, let's proceed. So we are coming to the doors. So let me write over here the doors. So for the doors, what can we realize? For the doors, what can we realize? You realize that let's come. They are just 3 doors over here. They are just 3 doors over here. So which one I want to start with? We can just also start with the 900 ones. Okay. We can start with the 900 ones. So we are still considering the external doors or the external doors. Yes. So the external doors, this one is 900, this one is also 900. So you see 2. So we come and say 900 times 2. It's simple as that. So 900 times 2. So here become 900 times 2. So I'm going to say 2 times 900. 2 times 900. So it's going to be about 0.90. So 0.90. Okay. Times, look at the height of the door. I don't want to see, but I want you to see it yourself. The door from the beginning they told us. And then the height of the door is 900. You see it over here. So all doors are what? No, the height is rather 2,100. Okay, that is just 7 feet. So 2,100 by what? 900. So the 900 is the length, the opening. So the 2,100 divided by 1,000, what are you going to get? You're going to get 2.10. 2.10. So the height is 2.10. So this is 2.10. 2.10. So very good. So here you just multiply. So if you multiply, you're going to get 3.78. So that is going to give us 3.78. 0.70. Then the last but not the least, let's come and take the double door. This double door over here. So this door, let me just this door over. Okay. So the last door we are trying to work on now is just this door over. You see this double door over. This double door over. You see. So that is what we're going to work. So that is the problem we are seeing over 1,500 by what? 1,500 divided by 1,000. You're going to get 1.5. So that is what we are going to use to calculate for the final opening of the door and then wrap up. So that is going to give us 1.50 times what? 2.10. That is the height of the room, 7 feet. No, it's not the height of the room, but the height of the door. The height of the door. Yes, so that is it. That's the one. So finally we can multiply this. And then we can write the answer. So when you multiply this, you are going to get 3.15. That is, this is 3.15. 3.15. Okay. So you can get our total answer from here. We add all, so we are going to add all these values over. We're going to add all these values, all of them over here in this column. Let's all quickly add it together and see the answer we are going to get. Let's all, at this point, let's all calculate add all these numbers together. Okay, so after adding all of this, you're going to get 7.10, please. 67.10. So let me put this on. 67.10. So that is what you are saying over there, 37.1. So we are going to get 37.28 rather. So it should be 37.28. So let's say 37.28. So I'm going to get 37.28. 37.28. You see 37.28. So now that you calculate on the other side of it, and then that is it. So you see that we are done for the for the external. So we can just come and go to the external work. Then we'll see how this become history. And we see how this become history. So from here, let's go to the next page. See how this. So we are done with the work. We are done with external work. So we are going to take the internal works. We're going to take the internal works. We do some short and we should do internal work. It's just something to you. Yes. At this point, good students should do well to like the video, comment, ask more questions, and also don't forget to subscribe to the channel. Thank you. So we want to take the internal walls. Then we talk about the internal walls, and then we see how best we can proceed or wrap up for today's class. So over here we are going to look at the internal walls. Okay. So that is the second one we are going to look at. That is the internal walls. So this is the internal walls. So it's the internal walls. So this is the internal walls. Okay. So we are going to do some few calculations for it now. We are good to go. So for the internal walls, as we did for the external walls, we're going to take the length. Okay. We're going to take the length. So let me write over here the length, and then step by step we proceed. So this is the length. And then for the length of the internal walls, we're going to be taking them in bits. Okay. So for the length of the internal walls, do have something. From the drawing, now I can clean all the lengths I have done in the drawing so that it can be a bit neat for us to use to analyze the problem we're about to answer. Since we are done with the external ones, why don't we kind of focus on the external ones a bit? Good. Since we are done with the external ones, why don't we focus on the internal ones? So let me clean all of this. Let me clean all of this very well. Also, I want to tell you that if you find this video very, very understanding, educative, don't forget to throw $1 on my name if you happen to see me in person. Yes, if you happen to see me in person, then push for 1.1. Very good. So let's go for the internal one. We are done with the external one. So I showed you initially when I used the blue marker pen to pass around the external. Now we are going to focus on the internal one. So into the internal was, look at let's start with this one. Look at anyone I pick, I'll just use something to underline it like this. So this one like this. This is 500. Okay, so I'm going to write it over there. But so 500. So that's the 500. Look at it is 5,000. It is 5,000. Okay. So 5,000 divided by 1,000, we get 5.00. So it's going to be 5.00. And then what next? Let's then take the other one, and then you see this is just for here. This is just for here. Then this long one over here, the end to end, it's what 8,750. 8,750. Good. So 8,750 divided by 1,000 gives us what? 8.750. So let's then write it. 8.750. So this is 8.750. all these ones are included. This one is included straight downwards. So what's next? Can we also take we are coming to also take you see these ones 4.2. Can you see 4.2? So this is one over here. 4,200. You see this 4,200. So this is that I'm second over here. See. So that one is 4.2. So this is it. And you realize that this is also one over here like this. That's so in the same dimension like that. So 4.2. You see, to avoid writing too much. And just come here out 2 times what? 4.2. So, and that is going to give me what? 8.40. 8.40. From here, what's next? Let's go to the which can we locate? Which can we locate? If you look at it, you can see over here 2, 1, 0, 0. So the 2, 1, 0, I'm going to count that. This is 1, 2. It's just 2. You see, this one is 300, so I can't include it. This one is 3,600, so I can't include it. This one. So the 2.10 is just 2, 1. See, so that's 1, so I'm going to say about 2, 1, 0, 0. Or let me see. 2 times what? 2.10. That is going to give me 4.20. 4.20. 4.20. Which other one again? Look at this one. The one I showed you, 3,600. This is it over here. So we can come and consider that one. So this one too is an internal 3,600. So if you divide it by 5, I'm going to get 3.600. So this also becomes just 1, 3.6. Then which other one is less than investigate when there is none, and then you see this one 3,000. So this one is how much? This one is 3,000. So this 3,000, right? That is the dimension over here. So I'm coming to put it over here. So this becomes what? 3,000. So 3,000 divided by 1,000, you're going to get what? 3.00. I can see some people complaining that the 8.75, they don't understand where it came from. So I intentionally left it there. I want to come and talk about it and to draw more attention. Even because of that, I will change different color pens to highlight it very, very, very. And that is, take note, the 8750 you are seeing is a combination of what? This dimension and then what? This dimension. You see that when I was doing, I didn't include these two people. I'll use different color pen to circle them, and then we add them and see if we get it. 8750. So everybody add 3900. Okay, plus 3600. What are you going to get? Good. So exactly. So I was saying that you should take note that here, you see that here is what? 3900. Okay. And from here to here, from the foundation, there is a block work. Okay. It's when you come up before even they come and fix the door. And then remember that after the length, the block work will continue. Then we are going to be doing subtraction for the doors and all of that. Okay. So we have to take the measurement in full. So realize that the before length from here to here is what? 5,000. Okay. So let's consider the 5,000. And then this 5,000 plus what? 150. Okay. The thickness of this wall over here is 150. Plus what? 3,600. We're going to get what? This value over here, which is what? 8750. So that is what? 5,000. This 5,000. Okay. This 5,000. So let me write it over here. 5,000, okay, plus 150. Okay. So the 150 is coming from here. This 150 wall. Okay. Plus what? Which one again? This 3,600. The 3,600 you have seen, right? From here to here is what? 3,600. Plus 3,600. So you realize that if you add all these people, 5,000 plus what? 150 plus 3,600. You're going to get 8750. Okay. So now I can circle this one and include it for you to see. So that is why I'm writing the 8750. You understand me? So to make things more understandable, you can come to the description sheet over here. And then what am I going to write? It's just as simple as that and easy to understand. Okay. Yes, it's just as simple as that and easy. I don't want to be writing in big to make you understand. That is why I just have to pick them and just pick all together as one, and that is the 8750. That is why you see it over there. For the rest, the rules are still the same. As simple as ABC. Okay. Good. Anyway, good students should remember to see me in groups, in person, one-on-one, so that better still I can explain to them differently. Any challenges in the course of lecture video. Good. So from here, we just have to add all of this. We just have to add all of this. You just have to add all of this. And if you add all of this, what are you going to get? If you add all of this, you are going to get 32.95. So that is 32. So that is that we had 32.95. So I'm just going to do my squaring, and then life is much more easier. So quickly, I'm going to write what? 32.95. Then I'm going to multiply it by the height of the room. They said the height of the room is what? 2,900. So that is what is going to give me the height that we did initially. So this is going to be 32.95. So that is 32.95. 32.95. That is 2.95 times 2.90, 2.90, 2.90. So this one, when you multiply the two, you are going to get 95.55. Let's all try together. So that is 32.95 times 2.90. You realize you are going to get 95.55. You can just run one and then you write 95.56. Okay. So against 95.56. Five point five. 95.5. Important. So from here we can just come and do our description. Quick, and then we have to quick. Yes, and quick. So our description, if it comes to the question, we are saying that blah, 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 and then all internal partitions are 150 hollow lightweight concrete block built in stretcher. You see, built in stretcher bond in cement and sand. So we are going to use these details in the description. As simple as ABC. Simple as ABC. So in correlation to our expense, 1 plus 1 plus 1 is the same. So internal wall here, we are going to say that what block word thickness 150 follow light with that is block word follow light with follow light with concrete block in stretcher bond and some ratio. Let's say 1 is to what 4, then internal was ratio 1 is to what 4. So we are done with the description. As simple as that. And then from here, you can just proceed to just do the rest of the story and then you have to do it. So let's come into that. Okay. The rest are still the same. Let's come into that and then we proceed. So we say that I need to do perfect inverted. Then we come into that. The doors. We realize that there are some internal doors. It's already put that. So we say that we need to work with that. dot what people. So that is just for the openings. What we are doing now is just for the openings. So we can pick out the openings, number of countries. So we're actually going for openings. Right. So number of countries. So the openings are simple as ABC. So the description is the same thing, and then the value we have over here is 32.95. The overall length, 32.95. We're going to multiply it by the length. You see, just like the initial one would be. So that is 32.95, 32.95. Okay, and what? 0.3, 0.23, 0.23. 32.95 and 0.23. And that one is going to give us what? 7.58. So this one is going to give us 7.58. And then so the other ones are going to be what? It's just the doors. This one is the length. So this one I did over here is for the length. So don't get confused. This one is for the length. Better still, to enhance understanding, it's good I write it so that a lot of people can be on the same side with me. Okay, so this is lentil. So the one I'm doing over here is for lentil. So that is it. And then this is what we said 32.95, 32.95, 32.95 times out 0.23 and 0.23. And that gives us 7 point, 7.58. 7.58. Okay. That was for the length. So now we are having to do for the door. And then the doors, let's go and count all the internal doors. So we are last we're going to do for the doors here, then we are done. So these are the doors. And for the doors, they are actually, we're going to count them now, don't worry. All of them, since the internal doors, their length was 900. So it's just a matter of knowing their number, and then you just use multiply that. That's so important. So come and see. Let me clean inside this, and then you just So let's count the internal doors now. So the internal doors, this is what? 1, 2, 3, 4, 5, 6, 7. You see, these ones are external. We've already calculated for them already. So these ones are 7. So it becomes 7 times what? So this one becomes 7 times 0.90. Their length is 900. 900 divided by 1000 is 0.90. Okay, 0.90 times the height 7 feet. 2,100. 2,100 divided by 1000 is 2.10. 2.1. Yeah. So we multiply all of this and then we get what? 13.3. That is 13.33. 13.23. So finally, if you add all of this, you're going to get what? 20.81. 20.81. 20.81. Good students can go out to punch all their questions in the comment section. Contributions are also welcome to enhance the study and the research process. The good students are welcome. Your comments are welcome. Do also type in the comment section. I will do also answer most of the questions in the challenges and it is also be affected and taken into consideration better research. Okay. So this is how far we have come for the superstructures. Okay. This is how far we have come in the superstructures. Okay. Yeah, so please on a very good piece. Let's all do well to watch the picture. Okay. Then good students will have a pen and a paper, a calculator beside them when they are always watching my lecture videos, so that they can be able to jot down something as they are watching. And these are some of the only ways you can be able to understand very, very, very well, because not everything I will be able to write on the board. Most of the vital points, I say them verbally. You see, I say them verbally. Okay. Yes. Also, don't forget to subscribe to my YouTube channel. Don't forget to like the videos. And then, most importantly, if you find this video very, very, very understanding and educative and encouraging, I will advise you to remember to put $1 on my name if you happen to see me in person in groups one-on-one, so that I can still be able to buy more data and be able to